The James Webb Telescope found strange signals from far away in the Andromeda galaxy. This discovery has made astronomers excited and curious about what could be out there in space. In the vast expanse of the cosmos lies a celestial marvel that has captured the imagination of astronomers and stargazers alike for centuries: the Andromeda galaxy. Situated millions of light-years away from Earth, Andromeda stands as a testament to the grandeur and complexity of the universe. Our journey to understand Andromeda begins with a humble glance at the night sky. Centuries ago, ancient civilizations looked up at the stars with wonder and awe, weaving myths and legends around the celestial bodies they observed. Little did they know that among the twinkling lights above, there existed galaxies, vast collections of stars, gas, and dust, each with its own unique story to tell. As humanity's understanding of the cosmos deepened, so too did our knowledge of Andromeda. Through the pioneering work of astronomers like Edwin Hubble and Charles Messier, we began to unravel the mysteries of this distant galaxy. Hubble's observations of Cepheid variable stars in Andromeda provided crucial evidence that it was a separate entity from our own Milky Way, forever altering our perception of the universe. Over the years, technological advancements have allowed us to peer deeper into the heart of Andromeda, revealing its intricate structure and dynamic processes. From the formation of new stars within its spiral arms to the presence of a supermassive black hole at its center, Andromeda continues to astound us with its complexity. But our fascination with Andromeda extends beyond its scientific significance. For many, the galaxy represents a symbol of exploration and discovery, a reminder of the boundless possibilities that await us beyond the confines of our own planet. As we gaze upon its distant glow, we are filled with a sense of wonder and curiosity, spurred on by the endless mysteries that lie beyond. Edwin Hubble's finding in the 1920s, using the 100-inch Hooker telescope at Mount Wilson Observatory, was groundbreaking. He discovered distant nebulae outside the Milky Way and proved that they were distinct galaxies, not part of our own. This finding transformed our knowledge of the universe and revealed the grandeur of the cosmos, with each galaxy having billions of stars. One of the closest galaxies he saw was the Andromeda galaxy, also known as M31. Edwin Hubble's observations of Cepheid variable stars in Andromeda in the 20th century provided critical evidence that it was a separate galaxy from our Milky Way, revolutionizing our understanding of the universe's scale and structure. This discovery paved the way for modern cosmology and deepened our appreciation for the vastness of the cosmos. In 1764, the famed French astronomer Charles Messier catalogued the Andromeda galaxy as M31 in his well-known Messier catalogue, incorrectly crediting its discovery to Simon Marius. However, this does not lessen Messier's contribution to putting Andromeda on the map. For nearly a century after these sightings, astronomers around the world strove to learn more about this fascinating galaxy, each adding to the previous one's discoveries. Prior to that, an Italian astronomer named Galileo Galilei transformed our understanding of the Milky Way in the early 17th century. Thomas Wright introduced a new concept in his work, claiming that the Milky Way was a flat layer rather than a random scattering of stars. He also speculated that a piece of this structure contained our solar system. While his hypothesis represented a tremendous breakthrough, it was limited by the observational technology of the time. It wasn't until 1864 that scientists made a key breakthrough in understanding the Andromeda galaxy. William Huggins made a revolutionary discovery when he analyzed the spectrum of Andromeda, finding its differences from ordinary gaseous nebulae. This paved the way for comprehending Andromeda as the galaxy it is, with a mass estimated to be 1 to 2 trillion times that of our Sun. If I were to continue your thought, it seems like you're pondering about the implications of this new understanding of the masses of Andromeda and the Milky Way. What are you curious about indeed? Contrasting the diameters of the Milky Way and Andromeda galaxy brings their enormous scales into perspective. Andromeda's diameter of approximately 220,000 light-years exceeds the Milky Way's estimated diameter, which ranges from 100,000 to 175,000 light-years. This stresses Andromeda's importance in the universe, as well as the challenges of correctly calculating galaxies' masses. Andromeda, at around 10 billion years old, is considered ancient in cosmic terms. The concept of its genesis through the merging of multiple smaller proto-galaxies adds to its magnificent aspect, implying a gradual creation over billions of years under the pull of gravity. The supermassive black hole at the center of the Andromeda galaxy exerts an enormous gravitational pull on the stars around it. These stars orbit the black hole in elliptical patterns, similar to how planets orbit the Sun in our solar system. At a particular point in their elliptical orbits, stars approach the black hole, a phenomenon known as perihelion. Gravitational forces are strongest here, therefore, the stars move at their fastest. This causes the stars to cluster and become increasingly concentrated in the region surrounding the black hole. As the stars cluster, they emit energy in the form of radiation. An AGN, or active galactic nucleus, is a high-energy area in the center of a galaxy. It is distinguished by increasing star density and radiation release, which provide important insights into gravitational dynamics and interactions with supermassive black holes. It appears that you are addressing active galactic nuclei, AGNs, and supermassive black holes, specifically in the context of the Andromeda galaxy. Because of the presence of a supermassive black hole at their center, AGNs emit strong light across a wide range of frequencies. These black holes are extremely dense places with a large amount of mass contained in a tiny volume. Observations with powerful telescopes, such as the Hubble Space Telescope, reveal fascinating phenomena in AGNs, which help us understand the universe. The phenomenon of 2 points of concentration of light and radiation in a galaxy, with one of them being the supermassive black hole slightly off the true galactic center. Supermassive black holes are indeed thought to be common in the centers of galaxies, including our own, the Milky Way. The active galactic nucleus, AGN, is fundamental to the evolution and dynamics of galaxies such as the Milky Way and Andromeda. When gas and stars come too close to a supermassive black hole, they build an accretion disk surrounding it. This disk heats up and releases powerful radiation at a variety of wavelengths, making the AGN extremely bright. Studying AGNs helps astronomers understand the processes driving galaxy evolution, as well as the behavior of supermassive black holes. Ring galaxies are fascinating celestial formations identified by their circular or elliptical ring-like features. Unlike conventional spiral galaxies, their rings are made up of bright, youthful, and blue stars, whereas the core region has comparatively little luminous matter. These distinguishing qualities set ring galaxies apart from the great assortment of galaxy configurations in the universe. Observed optical ring phenomena fall into 3 categories: nuclear rings, inner rings, and outer rings. Nuclear rings are found around the center of a galaxy, whereas inner and outer rings are further away. Ring galaxies are classified into O and P types. O-type ring galaxies contain nuclei in the center and smooth, regular-shaped rings, whereas P-type ring galaxies have nuclei that are off-center and more irregular. Ring galaxies are considered rare cosmic treasures. Astronomers have postulated mechanisms for the development of ring galaxies as well as their rarity. These mechanisms include galaxy collisions and the movement of smaller galaxies through larger ones. Ring galaxies created by galactic mergers include the Cartwheel Galaxy and the galaxy pair AM 2026. The collision of the Milky Way and Andromeda galaxy is a fascinating phenomenon, sometimes known as Milkomeda or Milkdromeda. While it is true that the merging process can result in bursts of star formation, which is exciting for cosmic evolution, the implications for humans are likely to be minor. Such catastrophes occur on a massive scale and over millions of years, and humanity will most likely have developed or relocated by that time. A spectacular celestial dance. As the galaxies merge, the gravitational forces will distort and rearrange the stars, creating new constellations and formations in the night sky. Shock waves and bursts of radiation will add to the cosmic light show, captivating observers on Earth. The merging process will not only reshape the appearance of the sky, but also influence the dynamics of stellar systems and the distribution of matter in the universe. It's a magnificent display of the ongoing evolution and interaction of galaxies in our cosmos. Significant environmental changes on Earth, and then transitioning to the interaction between galaxies. Environmental changes on Earth can indeed lead to disruptions in habitats, shifts in biodiversity, and local extinctions. Similarly, when galaxies approach each other, their gravitational forces cause distortions in shape and tidal interactions, leading to overlapping and potential destruction. The process of galactic merging is a gradual and complex event. During such mergers, different celestial bodies interact and alter dramatically, including the production of new star clusters and structures inside the newly combined galaxy. Furthermore, the supermassive black holes at the centers of both galaxies will eventually combine, resulting in an even larger black hole at the center of the newly created galaxy. Indeed, galactic collisions are a gradual process that takes billions of years. While it's exciting to think about, humanity's presence on Earth will most likely have evolved or died out by the time such occurrences occur. The chronology extends far beyond our current comprehension and existence. The transformation of our Sun into a red giant, followed by the engulfment of inner planets, including Earth, is a natural occurrence in the life cycle of stars. The collision of the Milky Way and Andromeda galaxies will have a substantial impact on the shape and composition of the new galaxy, regardless of whether it is elliptical or big disk. The outcome will be known only once the merger has occurred. Indeed, the interplay of cosmic forces and interactions among stars, gas and dust, can lead to the formation of new galactic structures. Within these merged galaxies, there may emerge star systems with planets orbiting in the habitable zone, where conditions could support the existence of liquid water, a crucial factor for the development and sustenance of life as we know it. This underscores the potential for diverse and fascinating ecosystems to emerge within the vast expanse of the universe. Understanding the stability of the new galactic structure is critical in determining the potential for life to thrive. Interactions between stars and gravitational disturbances may change planetary orbits and environmental circumstances, influencing the evolution and sustainability of life on habitable worlds. Furthermore, galaxy mergers may cause an increase in cosmic radiation and stellar activity, including unusual events such as supernovae and gamma-ray bursts, which could have an impact on the habitability of planets inside the new galactic structure. Predicting the actual occurrence of these events and their impact on planetary environments is challenging. If life were to emerge in the new galaxy, it would likely undergo adaptation to the specific conditions it encounters there. The prospect of life emerging in a new galaxy is tantalizing, with its environment presenting a myriad of physical and chemical properties that could foster the evolution of life forms distinct from those found on Earth. The unique conditions of this new galactic region could give rise to novel biochemical pathways, alternative genetic codes, and fundamentally different forms of metabolism. Such divergent evolutionary trajectories could lead to organisms with structures and functions unimaginable by Earth standards. The prospect of humans venturing into and surviving in a new galaxy poses a myriad of formidable challenges that must be addressed with ingenuity and advanced technology. Our biological makeup and physiological adaptations are finely tuned to the specific conditions of Earth, from the composition of the atmosphere to the availability of essential resources such as water and nutrients. These factors have shaped the evolution of life on our planet over millions of years, culminating in the complex organisms that inhabit it today. However, the environment of a new galaxy, such as the one we may encounter beyond Andromeda, is likely to be vastly different from our own. The atmospheric composition, gravitational forces, and availability of resources may vary significantly, presenting significant hurdles for human survival and colonization. Without technological advancements or genetic modifications to adapt our biology to these alien environments, the prospect of sustained human habitation in a new galaxy remains remote at best. Despite these challenges, the mere possibility of encountering life forms shaped by alien environments ignites a profound sense of curiosity and drives scientific inquiry. Exploring the potential diversity of life in the universe not only expands our understanding of biology and evolution, but also pushes the boundaries of what we know about the origins and possibilities of life itself. The study of extraterrestrial life forms offers tantalizing insights into the fundamental processes that govern life's emergence and evolution, shedding light on the universal principles that underpin the existence of living organisms. While humans of today may not be equipped for survival in the new galaxy, the exploration of its potential inhabitants holds promise for unraveling the mysteries of life beyond our solar system. By studying the adaptations and survival strategies of alien life forms, scientists can gain invaluable insights into the fundamental mechanisms of life, from its molecular building blocks to its complex ecological interactions. Moreover, the discovery of extraterrestrial life would revolutionize our understanding of the cosmos and our place within it, challenging long-held assumptions about the uniqueness of life on Earth and the prevalence of life elsewhere in the universe.